Hello, Matthew. All right. Well, hello, Matthew. All right, for those of you watching the recording, we've got about 2 minutes to go, so there might be quiet for the next minute or so, and then I'm going to get started by reviewing, well, whatever anybody wants me to review, but also starting on Lab 2. Yes, Lab 2 is where I was going to go. Was there anything in particular you wanted today? Is it Lab 2 was your focus? All right. Well, we'll just kind of go with Lab 2. So, welcome, Dylan. Is there anything in particular you wanted me to go over tonight? I thought I would kind of review Lab 2, but if there's something else, I'd rather focus on that first. Sure. What would you like me to review? Yeah, no problem. Well, let's go ahead and I'll just create a whole new thing. So let's just say um, we're going to do a brand new project. So let me save this project. Um, So I'm just going to call it the Week 5 Q&A project, okay? So you're starting at this point with this particular thing, and you're given a problem description defining the actual problem. So I'm just going to come up with a different one so that you'll know, it'll be very similar but not exactly the same. So instead of doing the homeowner or club member kind of assignment that you were given there, let's not do the dog because it seems like we've done that one to death. Why don't we do let's see, what could we do? We can do a patient. Okay. So we're going to do a new class, and the name of our class given is patient. So that's going to be the name here. And remember, classes, the naming convention for classes is that they always start with a capital letter. So we're going to start patient with a capital letter. Okay. And we're just going to click OK or enter here. And it will create for us a patient class. Now it's going to give us some stuff to help us out. BlueJ tries to be helpful by saying, all right, you need your author name up here at the top and maybe your version number, so it gives you the opening Java doc. And then it tells you you're going to need some instance variables, that you're going to need a constructor, and then it just gives you a sample method here that you can kind of use to get you started. So you don't have to use any of these things. They're just here for suggestions. But it did name our class patient. So let's say, for instance, that we're told that there's 3 instance variables for our patient, that there is the name of our patient, the age of our patient, okay, and then the, what else do we want to go with? Gender of our patient, which will be a character, gender, and that will contain a value. We could have gone with room number. I didn't see that in time, but we'll say gender, but this will be a character of F or M for female or male. Okay. So then we're going to have a constructor. And to match what the assignment was, we're going to say all we have is the empty or the default constructor, and that the purpose is to initialize our instance variables to default values. Okay, so we're going to go with unknown, 0, and then just a space for the gender. So it's always a good idea to reference our instance variables using the keyword this. So this dot name equals unknown. Okay, this dot age equals 0. And this dot gender equals, and gender is single quotes. Okay, and I'm actually starting this backwards, aren't I? Because we're supposed to start with the test case, not with the class. So let me just kind of set this aside and jump over here and do the test class. So we've created this class, and we'll create a new class for our test class. So new class, and we're going to call it patient test. And we're going to choose unit test here to be a unit test class. And again, BlueJ is going to kind of be helpful for us and give us some stuff. They've got the setup and the teardown, which we're going to use that in lab 4 for sure, maybe in lab 3. We'll start using the setup and teardown, but for right now we're not. So, and they even kind of tell us, create the object, assert something, call the method, assert something. So they kind of give you even some examples as to what you're supposed to do, but we know that we're always supposed to create the object that we're testing, call the method, do any setup work that we need to, call the method that we're testing, and then verify that it worked the way that it's supposed to. Now, in the case of the constructor, so if we test that first, so we'll test the constructor here. We need to call the constructor that we're testing, but we only have one constructor, which is our empty or default constructor. So we're going to call it, and it's always the same format, your class name, which our class is patient, and then some object name. I'm going to go with pate1 equals new patient. And all we have is the empty or default constructor available to us in our problem description, so that's the only one that we can call, so nothing in our explicit parameters. The next thing we do when we're testing a constructor is we do an assert not null of that object. So if it was equal to null, it would mean that it contained no values. But we know that when our constructor is done, it should initialize our instance variables to default values or to the to something. So our object should contain a value. It shouldn't be equal to null, so it should contain a value. If it is equal to null, then something didn't work the way that it was supposed to. Okay. All right, and then the next thing we need to do, that we're not done yet, this is just the initial, we know that the whole purpose of this default constructor is to set our instance variables equal to default values, so we need to check that. So we need to do an assert equals, and we know that our name should be set equal to unknown, and that would have been in your problem description, right? And you also knew what the name of your method was, so it'll be patient1. And we haven't defined ours yet, but we'll have it get name, okay? And so that's going to retrieve the name of our object and compare it to the value of unknown. And this value would have been given to you in the problem description. Oh, well, you keep typing. Type in your question? Was it more on the set and gets, the test cases for the set and gets? Oh, yeah, you don't. Oh, that's a great question. Get gender. You don't have to have a separate test case for both the set and the get. Because you, like you said, in order to test the set, well, we're calling the get method all the time, right? So here I'm calling all three get methods when I'm testing my constructor. So I'm testing my get methods here, and then in the set method, you're also testing your gets. So you don't really need to test, you can test your get separately if you want to, but you don't have to do a separate test for the get. Now the set method, of course, because that requires a call to the set, you're going to need test cases for that. But the get method is just a retrieve, so you don't have to have a separate test case for the gets. Did that explain that well? Okay, cool. So you don't need me to finish this. Matthew, did you want me to go ahead and go through this example, or are you good with this sort of, or all right, well, I'll just go ahead, and it shouldn't take very long to whip through this. And if you guys have other questions, go ahead and type them out there. And I'll just finish this up real quick because there's not a ton to it. And then we'll move on to lab 2. But if you have other questions, please type them in there and I will make sure we get those addressed. Okay. So that tests the constructor. You want to make sure you test all the instance variables to ensure that they contain the value that you're submitting. I know several students omitted this part, and that is not a sufficient test of the constructor because you have to, the whole purpose of the constructor is to not only create the object, but to initialize it to default values. So you need to check and make sure that it actually did what it was supposed to. So we can test the set name method, okay? So again, we still have to create our object. We do not need to do the assert not null now because we've already tested our constructor, so we're going to feel confident that our object is created correctly when we call our constructor. But what we do need to do is call our set name method, which is the method that we're testing, and maybe we set it equal to Joe. So then down here, if it worked, we would expect it to be equal to Joe. And we could actually call this a couple different times just to verify, so maybe the first time it's equal to Joe, and then the next time we set it equal to Sam. And we would expect if I call it the second time that now it would be equal to Sam. Okay. And we'll go ahead and test for the gender and for the age. And I'm just randomly picking values. Now, 14. We haven't gotten into conditional statements yet, but what we would most likely do is do a patient 1 to make sure that it really worked properly, set age, like -1, because that shouldn't work, right? And age should be 0 or higher, so we would want to then check to make sure that our age did not change. So it should still be equal to 14 at this point if we enter an invalid age. And maybe there's an upper limit too that we're going to say our age has to be less than 130 or something like that. So now we could try to set an age of 140, which is way too high, and then again, that should not work. So 14 would still be the age. So we set it to 14, we checked it, but then we could set it to some values that we know it should not work and make sure that it didn't change it, that it's still equal to the original value. Okay. And then the last we would need to do is test our gender. All right, so we would do a patient1.setGender, and then again, it's a single quote for the character, so we can set it equal to an F, and then we would expect our gender to be set equal to an F. Then we could do it again and set it equal to an M, and we would think that would work as well. And then we can try setting it to something else, and that should not work because the only two valid genders we should have are an M or an F. So we could try a Q, and it shouldn't work, and it should still be equal to an M. Okay? So this won't compile right now because I haven't written the classes, but these are things that I can work through and figure out as far as my test cases. So then over here, we've written our constructor, so it's set our values, and then we need to do our set and gets for each one of our instance variables. So the sets are going to return data type void in this particular situation. So we'll have our set name, but that is going to expect a string value, and I'm going to call it in name, and we're going to set this dot name equal to in name. Okay, and I'm going to copy this guy and do my 3 sets all in a row. So I'll do my set age and my set gender. Now the age is data types integer, and my gender is data type char. And again, I'm just choosing in name, in age, and in gender just because that's kind of a standard I've developed for myself that I like because it shows that stuff is coming in. You don't have to choose those. I would suggest, however, that you not choose the same name as your instance variable, because if this is name and your instance variable is name, it just gets confusing to go like name equals name and stuff, and so you can kind of confuse your explicit parameter with your instance variable. So I would recommend that you not choose the same name as your instance variable, but you could call it new age, you could call it age 1, you could call it whatever you wanted to. This is just what I have chosen. Now, I did some things with the age and the gender, so I'm going to need to put some conditional logic in here. I think we're going to talk about it this week, actually. So if in age is greater than or equal to 0 and in age is less than or equal to 130, then we'll go ahead and set the age. And likewise for the gender, if in gender equals M, or, oops, this is not and. Sorry, I'm screwing up. I teach Python right before this, and so I'm confusing my Python with my Java. In gender equals female. Then set the gender. Okay, so those are my sets, and then I need to write my gets. Why are you not tabbing over? All right. So public string get name, no explicit parameters. We're just going to return this dot name. Public integer get age, no explicit parameters again. We're going to return this dot age. and public char get gender, and we're going to return this .gender. All right, let's see what sort of weird typo errors I did. All right, we compiled clean. We compiled clean. Oh, no, we did not. Missing a semicolon. And here as well. Okay, we all compiled clean there. Test all. Yep, and I failed one of my tests, which was the set name. Oh, I misspelled my test case. Expecting Sam with an E, but what I got was Sam without an E. And so I'm guessing, yeah, I mistyped it right there. So now I can test all, and then it passes all of my test cases. All right, so any questions or anything you want to know, like why did you do it that way, or what did you do here? Or did this just kind of help reinforce for you guys what you're already figuring out? Okay, great. So let's move on to Lab 2 then, unless you have something else. Is there something else that you guys want me to go over before we head to Lab 2? All right, well, if something comes up, let me know. All right, so in Lab 2, good news and bad news. So the bad news is we're still doing golf, all right? But so they've come up, they like what we did so far with Lab 1, and they're going to do some additional stuff. Okay, so what we're going to have is this golf swing video game kind of a thing. So it's like a tool that helps people determine how effective their golf swing is. All right, so here you've got your simulator, you've got a display, you've got the club, you've got sensors, you've got everything, and it's going to compute the loft, length, speed, and distance. All right, so information about the swing. Blah, 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 blah. Okay. So we're going to develop this golf simulator class. So this is what's going to be written in this particular Lab 2 is a golf simulator class. We're going to use test-driven development, so we'll have a golf simulator test class as well to verify what we've written in our golf class. Okay, so here's the, we've got a potential of a golfer, a sensor, or the display. So all of these could be a source of input. So if they hit the reset button, that is simulating creating calling the constructor. So we're going to create our golf simulator object. So if they hit the reset button, they're basically saying, let's start to play, right? I want to play a new round. So we're going to create a new object. If they have a club number from 2 to 9 are valid club numbers, so nothing below 2, nothing greater than 9, then we're going to call the set club number method to set what the club is that's being used. When they sense a swing, they're going to record the swing, so that records the strength of the last swing, and it's going to be somewhere from 0 to 10, so it's not going to be greater than 10. All right, and then the display also could request the club number, so that would be your get club number method. You're going to compute the loft, the length, the speed in yards per second, the speed in meters per second, the distance in yard, and the distance in meters. Now don't worry, they're going to give you the calculations for these. Okay. So you ask what value to assign to the club when the simulator is reset. So what are the default values for the constructor? So the club number, the default value for the club is a 9 when you call the constructor, and the swing is a 0. So those are your default values that your constructor is going to set the instance variables equal to. Here are your formulas for calculating each of the formulas that they wanted up here, the loft, the length, the yards per second, the meters per second. And so here's these formulas. Now they look really confusing, but they're not as confusing as you would think. All right, because you're going to know you're going to know this information. All right. So, and here we go. The formulas seem complex. You're not sure you can code calculations that you don't understand. And John tells you that a golf swing is very complicated. So far they're not giving you a lot of reinforcement, right? But the constants in the table below are easily modified to frequently tweak their values. So you're going to have a lot of constants to use, okay? So you're going to define these as final values in Java. So remember we talked last week that when you're defining a constant, it has the keyword final in it, meaning it's the final value for that particular variable. So it's not static. Static belongs to the class. It's final, as in the final value. So here we go. B sub loft has a value of 10.2. So these are constants. C sub loft has a value of 2.78. B sub length is 53.5. C sub length is a negative 1.84. And then the B sub speed, C sub speed, K sub speed, and C sub distance. So all of these are constant values. So up here, B sub loft is constant, C sub loft is constant, and then the number of your club, which is going to be from 2 to 9, right? And then this is in degrees, but you'll need to convert it to radians. Good names for these. Let's see if they gave us some names for these. No, they did not give you any. Oh, I think they're defined further down. So in the calculator, we don't need them to be a constant for the whole program because we're only using them in certain methods. So when you're calculating the loft, they went with loft base versus loft coefficient. So your loft base is your B sub loft and loft coefficient is your C sub loft. So those were just the values that they used for those. You can choose whatever you want. You know, you could even call them B loft and C loft if that helps you to follow those formulas around. You can make them global. WebCat may complain a little bit, so you might want to see what WebCat does because it may be like, you know, you made these global, but you only use them in one place, so why not just stick them in that one place? So you'd have to kind of check to see if WebCat complains in the coding style location. That may be why it's been put inside of these methods. Okay. Let's see, I'm just trying to look to see. You implement the first class with 2 instance variables, use club number and last swing to record the strength of the last swing that was sensed. So you have 2 instance variables. Okay, so here you talk about the constants. You choose this. So here's the naming conventions that they chose for the constants. And this is out on Piazza. You can download these. So loft base, C sub loft would be loft coefficient, length base, you know, so you chose these sorts of words here for our constants. When a constant is used in only one calculation, you decide to declare it in the method as opposed to making it a global constant. All caps when it's a global constant. Okay. Code calculations only once in a class. So I'll talk about what that is in a minute. Well, here we go. Implementing the compute distance in meters method. Rather than repeating the compute distance in yards, you just call your compute distance in yards and then convert it into meters using the conversion value. Okay. And you open your Big Java e-textbook to page 139 to see the list of the math class. So you can also go out to the Java docs and look for the math class as well. Oh, don't worry about it. You know what? Read this thing 100 times and it could be something different every single time. Oh, there's supposed to be a spreadsheet. I don't think he gave you guys the spreadsheet. I do not think that that was uploaded, so I will make sure I upload that. Let me see if I'm pretty sure I've got that. So what we'll do is we'll give you this spreadsheet here. I'll get a hold of Edgar and have him send it out. What this spreadsheet here does is it just gives you some test values. Okay, so you could say I have club number 4 and my strength was a 6.2, and then it calculates all the values for you. So if you're putting, when you're writing your test cases, instead of having to manually calculate all these numbers, you could come out here and go, this is club 7, my strength is a 3.8, and these are the values that I should get for all of them. So it just helps you with writing your test cases. So I'll make sure that Edgar posts that out to Piazza. If he doesn't, then I'll stick this version out there. Okay, so, and again, you're going to submit to WebCat, compile, run your test cases, and submit to WebCat. All right, so let's take a look at what we've got here. Come on, work with me here. So we've got our class, and then we've got our test class as well. So we encourage you to start with the test class. We know that for that default constructor that our club number should be 9 and our swing should be 0. So we're going to create our object. We only have a default constructor. We don't have any other constructors in here. So just one constructor, the empty or the default constructor. The whole purpose is to set it to default values, and the Word document told us the default club is a 9. So get the club is a 9, and that the last swing is a 0.0 strength. So we call our constructor, assert that it's not equal to null, and then check the 2 instance variables to make sure they're equal to the default values. Set club, we call our constructor every single time, create our object, then we're going to call our set club. You need to set it to something different. Setting this equal to 9 would not be an appropriate test. The constructor sets it to 9. You need to change it to a completely different value in order to know that it works. But it needs to be a value from 2 to 9, right? So you need to, theoretically, you should set it to some value that you know would work, but then you should also set it for a value that's too low, like 1 or lower, and something that's too high, a 10 or higher, just to make sure that it only gets set equal to a 2.9. I'm not sure if we're doing that at this point, but we will at some point in time in our lab set. Record swing. Now this one is going to record the new swing strength, and then you need to test whether it was successfully changed. So again, you will call the record last swing with the swing strength, right? So that replaces the swing strength, and it needs to be from, is it 0 to 10? So you need to call it with a value from 0 to 10 and set that. So the sets and gets will become really familiar with you. Those are very straightforward. All right, now computing the loft. So this is where you're going to want to take advantage of that spreadsheet. So you'll have to create your object, and then you're going to set your golf club. You're going to then calculate the loft. The loft calculation, where'd my Word document go? Is B sub loft plus C sub loft times by the club number. So it does not have anything to do with the swing strength, so you don't have to worry about setting your swing strength at this point. You're going to set your club number, and here they chose 8, but then you can come out to that spreadsheet and say, all right, if I do an 8, then my loft, which is, what is the loft? Where did I go? Calculate loft. I just like, which one of these is the loft? Well, it's not the speed. It's not the distance. Well, let's see. It's the radians. It's the angle. Club angle is your loft. So 0.5662, if this is an 8, it doesn't matter what the strength is, 9.7, no matter what I change it, my radians stay the same, 0.5662. So you can use your spreadsheet, putting in a different club number, and you can get your loft. Okay, and then you should change it to another, well here they've got number 2, and you need to calculate the loft. So you need to fill in these 2 values here. The club length is B sub length plus C sub length times by the club number. So again, that is not impacted by the swing. So again, they're doing club of 8 and they're saying this. You want to verify that. So let's see if our length matches the spreadsheet, 38.78. And then they change it to a club number of 3. And now it's 47.98, which is what they've got there. So those two values are correct. Then you're going to calculate the yards per second. So again, create your object. Now you have to set both the club number and the swing. You're going to get rid of this assert true, comma false. This forces your test case to fail. So you want to call your method that calculates the yards per second, just like we do up here, but you're going to figure out what that value is. And again, you can just come in here and do the 5 and then the whatever it is, 7.8. And then here, yards per second is 52.1802. And meters per second, 47.7135. So you're going to call it, and then you're changing the swing to a different value, and then call it. And so then you're going to replace these two statements right here with your appropriate test cases. Okay, testing for meters per second. Basically, you're going to simulate this, but everywhere up here that you called the yards per second, you're going to change it to meters per second down here. And definitely get rid of these assert true statements. Distance in yards, same thing. Create your object, set your club, set your swing, and then call your method here. Change it to a different value, call your method again, and what values you're expecting. And the distance in meters, the exact same format. Create your object, set your swing, or set your club limit to your swing, call your method with what you're expecting, and call it again. And like I said, this spreadsheet will give you all of those values. So you should be able to fill in all of your test cases and feel confident that the values are correct. All right. Once you've done all of your test cases, then you're ready to start working on your program. And where did my program go? Here we go. Okay. So where I would start is first the constructors and then the 2 sets and 2 gets. And I would just stop right there. All right. So I would start with my constructor. You know what the 2 values are supposed to be equal to, right? Your club number is set to a default value of 9. The last swing is set to a default value of 0.0. So set your instance variables equal to the default values. Your set club number, it's already done for you. It's set equal to the new club explicit parameter. The get club number is also done. So you're going to be writing the get last swing and the record last swing. So those are just setting your swing strength, either returning your swing strength instance or last swing instance variable or recording into that. So you're just going to use your set and get for the club. It's a model for what you're doing down right here. Okay, and then I would stop, compile, run your test cases, and make sure that your test cases for the constructor and the sets and the gets work for your instance variables. Because the reality is if they don't work, nothing else is going to work, right? So make sure those ones work. Then come back in and start with the 2, the loft and the link calculations. Okay, start with those guys first. Because they don't require the swing, right? And they're the easier 2 calculations. So start with those 2 calculations. So let's look at calculate loft first, since it's already in here for you. So we need to know the B sub loft and C sub loft constant values. So those were defined right here. And then the club number, which is our instance variable up at the top. So we're going to add the B sub loft plus the C sub loft multiplied by the club number. So loft base. So here's what I do, all right? I take the calculation and I just copy it right here. Better. I would copy it better. It's not copying because of the word, but it would be loft plus C loft times by the club number. And I know that's in degrees and I've got to convert it to radians. So I would first work on just this thing. So the club number, I know what that is, right? I would go up to my instance variable and that is going to be club number. and I would just replace that in my formula. So this dot club number. The B sub loft, I just define that right here as loft base. So this is a local variable set to the value of 10.2. So I would copy that and replace that with the indicator in my formula. The C sub loft, I define that right here. So I would copy that and replace that in my formula. And now I've got this formula right here that looked all complicated over there. I've now put it over here, right? So I can set this probably a double whenever you're dealing with tangents and this sort of stuff. It's going to be a double, whatever you wanted to call this, loft equals. Okay, so you can set this equal to this value, which is what has been provided for you right here. So I'm going to get rid of that. And then you need to convert this from degrees into radians, and that's what's happening right here. Math.to radians, the loft in degrees that you just calculated. All right, so if we take the same sort of thing for the length up here, which is what we've got going on right here, okay, so we know the length is calculated as the B sub length plus the C sub length times by the club number. Okay, so we know that this is what the club length equals. So this would be a double data type. So B sub length, if we come down here, we know B sub length is 53.5. So as you did down here, you're going to just create a variable maybe called length base or something like that. You're going to define it with a value of 53.5. And then you're going to use that variable name right here. Okay, then you'll define a variable called C sub length with a negative 1.84, and you're going to put that variable name right here. And then of course club number is the name of your instance variable. So you're going to plug in your instance variable name right there. You can do your whole calculation and then return the value that you've just computed. All right. So you guys following this? Is it becoming less scary to think about these formulas over here now that you see what we're doing on this end? Right. Okay, great. So then what I would do is just stop right here. You've got two formulas done. You know your constructor works. You know your set and get works. You're going to run through these two formulas. And now that you've written them, and compile it and run your test cases and make sure these two formulas work, right? No sense in going through everything, because what happens is if you write this whole thing all out at once, you're going to make errors, right? It's the nature of the beast. There's going to be errors that occur in this. And then you're going to be jumping all over the place trying to fix these. Oh, I've got an error here. I've got an error here. And you're not going to be focusing on any one task. Where if we just work on two, or maybe even just do one at a time, like just do the well, you know that the loft is already done for you, so that should work. Maybe all you then do is calculate the club length formula and compile it and test that and make sure that works. And then work on them one at a time, just making sure each one works as you go down through the formulas. And that way you won't get, you won't be bebopping all over. You won't be like, oh, I think I need to do this, I need to do that, and making mistakes or maybe confusing the formulas. You'll just be working on things one at a time, and it'll really make it much more straightforward. And you know too, you have a clean stopping space. If you're like, all right, I have 1 hour to devote to this tonight, and you're able to knock out the constructors and the sets and gets, count that as a win, and then when you come back the next time, work on calculating the length. And maybe you only have an hour that night, but you can do the length and the calculate years, yards per second, and that's okay as well. Okay, yards per second. Speed here is yards per second right there, okay? So they've already defined for you the different constants that you're going to need, and then they broke it down even, they actually did the whole calculation for you in yards per second, so you're not going to need to do that. Now, meters per second, remember in here it said, don't reinvent the wheel. Code calculations only once in a class. So you don't want to do the whole speed calculation again and then convert it into meters. You already know what the result of your of your yards per second is, right? So just call that method. And to call a method, it would be double, maybe call it YPS equals this dot calculate yards per second. Okay, so what this does, this dot says this implicit object, right? I want you to call the method for this implicit object using these instance variables. So it will go up and call this method right here and execute it and return the value into your YPS. Then you can just convert this YPS into meters by multiplying or dividing whatever it is by the coefficient that converts it. So I think we have yards per, or meters per yard equals 0.9144. So there's 0.9144 yard in, no, 0.9144 meter in every yard. So you'll just multiply that down here to convert. So multiply your yards per second by your meters and it gives you your meters per second. Okay, so just do that one and get that one working and make sure it passes your test cases. The distance, didn't we just do the distance? No. We did the speed and then the distance per yard. Here's the formula for it, a little bit more complicated because you've got an exponent going on there and you've got the sign. So they only gave you one constant here. You're going to need the speed for the club. This is a distance in yard, not the distance in meters. So again, you need to know what your speed is. So again, call your, just like we did here, call your calculate yards per second. Okay. And then you'll multiply it by k speed times length. Oh, I'm sorry. I keep moving, or I keep going into the wrong one. You got your speed squared. Okay, so you're going to need to use the math POW, and then multiply that by the math sign 2 times the loft of the club, which the loft, you've got the loft method up there as well. So you're going to do this dot loft to calculate that. So I would first, since you need to know, you got the distance, right? Here's your distance coefficient. You know, I would go ahead and define your next ones. It's not going to be a final, but a double yards per second equals, and then call your method to calculate the yards per second. And then you need to know the loft. So I would go ahead with your double loft equals, and then call the method that computes the loft. And that gives you all of these different variables, c sub distance, speed, and loft. And then you're going to need to do the math formulas to calculate these all out. And again, if you kind of just put this in there, then you can just replace the different things with the variables and call your different math functions. So it'll be math dot, is it a capital M? Yeah, math dot POW, which is power raised to the power. So we would do our speed, our yards per second raised to the power of 2. Okay. You have your math dot sign, which is then 2 times by your loft there. And so you're like multiplying the distance times by the speed squared times by the sign of 2 times the loft. So you calculate that and return that value. Down here, you're calculating the distance in meters, so it's essentially the same formula, but instead of a yards per second, you're doing meters per second. Okay, but I would get this working first, and then once it tests completely, come down here to this guy and get it working. All right, I kind of jumped around through there. What do you guys think? Other than having to watch the video a few dozen times, what do you guys think about all this? Did any questions come up? No, it's really not that challenging, especially with that spreadsheet that calculates all the values for you for your test cases, right? Yeah, so just don't let these formulas overwhelm you because all these things are like constants, right? So just keep that in mind that everything is a constant and that you're just plugging values into the formulas. All right, do you guys have any other questions? Anything else that you'd like me to cover tonight? All right, well then we're just going to go ahead and call it an evening. I will make sure I get that spreadsheet posted out to Piazza with Lab 2 so that you guys can use that to assist you in generating your test cases. Other than that, have a great evening. Don't forget that I'll definitely mention this during Thursday's meet session, but next week is this is week 5. Next week is week 6, which is the midterm. So keep that forefront that you'll be scheduling your midterm for next week. And I'll send an email out probably tomorrow and go over it on Thursday as well. So just a reminder. Okay, so the issue is, Matthew, I submitted the tests to the testing center on Monday, and I haven't gotten back from them yet that they've completed processing them. Probably by tomorrow they'll complete processing, so you can't schedule with ProctorU until they're done processing. So what happens is I send to them and say, hey, I want this test on this date, in this date range, and I give them all the particulars about the test, and then they transfer all the test information to the proctors. So they probably just haven't finished doing the proctor transfer yet. So I would expect tomorrow that will be completed, and then you'll be able to see it on ProctorU and you'll be able to schedule your test. Yes. Actually, by Thursday. It should definitely be there by Thursday. So let me know if it's not there by Thursday, and I'll just double check with the testing center. All right. You have a great night.